Alright guys, welcome back. So hello, it's me again, Mr. Chen. And today I just want to talk about the continuations of the rest of the final study packet. So number 22 all the way to number 40. Okay, so last time we talked about some of the conic section problems, sequences in series, and also like some of the trig problem, like using the law of sine to find out the missing segments, using SOHCAHTOA to find out the height of the triangle so we can find the area, and etc. And now 22, so the other part of the conic section. So conic, we do have circle, ellipsis, hyperbola, and parabola. Parabola, we'll get to that in the later video. And then 22, so this one, it's all about the hyperbola. Okay, so this one, let me just put into the new slide. Okay, so for number 22, and you might be wondering with the negative variable quadratic expressions, so how do you deal with this? So this one, normally we started out with the positive variable quadratic expression, so that's y squared. So started out with y squared first. And again, you want to group the like terms. So 2y. And then minus, well this one, let's put it this way, plus negative x squared with the like terms, so plus 6x. And then blank. So that equals 12. Because negative 12, so once you add 12 on both sides, you'll get 12 of, negative 12 got cancelled. Then you just move on to the right hand side. And now this one, just want to complete the square, so F1 right here. And then for the other one, you want to take out something first. So you want to pull out the negative 1. Okay, so take out negative 1. So we got x squared minus 6x plus blank, so equals 12. Well, this one is already done, so let's just keep it that way. And then complete the square, so this one, negative 6 over 2 quantity square, so it's 9. Now, got to be very careful. Looks like we're adding 9 on the left-hand side, but the things that, remember, since we took out negative 1, so we're actually adding negative 9. So this one, add 1, and then subtract 9. So factor it, so we do have y plus 1 quantity square, minus x minus 3 quantity square. So 12 plus 1, 13. 13 minus 9, and that'd be 4. And the final step here, you want to divide by 4 for each term, because for the constant, you want to convert that to 1. So what we got here is y plus 1 quantity square over 4. Minus the quantity of x minus 3 squared over 4. So the value of h comma k, so this one is 3 comma negative 1. And then for the value of b squared, so b squared is 4. So that means b is 2. A squared is 4. So a is 2. So started out with 3, negative 1. So 3, negative 1. So 3 to the right, down 1. And then this one looks like it's a vertical hyperbola. And then for the value b, so 2 units up, 1, 2. 1, 2 unit down. 2 units to the right, 2 units to the left. And then from here, we want to set up the imaginary box. And the purpose of doing that is we want to set up the slant asymptotes. Again, the slant asymptote can be always constructed by using the corner of the imaginary box. So simply connect all the points from the corner to the corner and the center. And then we do know that the vertices, so this one is 3 comma 1, and then the other one it's 3 comma negative 3. And then from there, just make the vertical hyperbola. Okay, well this one's over the limit here. So this one, let's just make sure that it's got to be bounded in between the slant asymptotes. okay, for the hyperbola. And here's what we found. Okay, so now let's see what else for the packet. And the next type of problem, it's all about the long divisions and also the P over Q theorem. Or factoring, finding all the roots. Well, anytime they see the keyword, okay, so factor to the linear and the irreducible quadratic factor. So that means we need to find all the roots. So one root is given already, which is 3 plus root 5, irrational. So now anytime they see the irrational root, it's given. So it's conjugate, it's also the other root. So this one is called the conjugate theorem, or the conjugate root theorem. So let's say that the positive root is given, so it's negative, it's also the second root. Okay, so let me just snip this one and then put into the new slide. Just want to get more space for this right here. Okay, so somehow this one is not working. There you go. So using the conjugate root theorem, so we can find out the other root. Now, but the thing is that, what about for the rest of the roots? How do we find out the rest of the root? So since we do know that one of the factors is considered x minus the quantity of 3 plus root 5, and then the other factor, it's x minus the quantity of 3 minus root 5. So this one, try to regroup them. So this one is x minus 3 minus root 5 times x minus 3 plus root 5. And by using the quadratic, the conjugate difference of two square pattern, so this one is just like a, this one here's b, here's a, and here's b. So multiplied it out, so this one, the divisor will be considered x minus 3 quantity square. So negative root 5 times positive root 5, so that means minus 5. And then try to expand it. So x squared minus 6x plus 9 minus 5. This one you can FOIL if you don't know what I'm doing here. So basically what I'm doing, I'm just applying the perfect square pattern. So x squared minus 6x plus 4. So this one would be the new divisor. And we do know that the original polynomial, so x to the 5th power minus ax to the power 4 plus ax cubed plus 40x squared minus 32x. And then you can say that the constant term is 0. Divided by the quadratic trinomial. So in order to get rid of that x to the power 5, so we need to start it off with the first 3 terms. So x to the power of 3. Okay, so excuse me for a second. Okay, so let's continue with the lecture. Okay, so x to the power of 3, x squared, so it's x to the power of 5. And then x cubed minus times negative 6x, so it's negative 6x to the power of 4. X cubed times 4, then it's 4x cubed. Subtract, so this one got cancelled. So negative ax to the power of 4 minus negative 6x to the power of 4, negative 2x to the power of 4. And then this one, 4x cubed. Bring down 40x squared. And then in order to get rid of that, negative 2x to the power of 4, so we multiply by negative 2x squared. So negative 2x to the power of 4, 12, x cubed, and then negative 8, x squared. Again, subtract the first group here, so this one got cancelled. So 4x cubed minus 12x cubed, so it's negative ax cubed. And then 40x squared minus ax squared, so plus 48x squared. And bring down negative 32x. So this time we need to multiply this one by negative ax. So this one turns out to be negative ax cubed, negative 48x squared, and then negative 32x. So basically everything got canceled. There's no remainder. Or we can say the remainder is 0. So this one can be factored into x squared minus 6x plus 4, the original divisor, using the conjugate root theorem. And then the quotient, x cubed minus 2x squared minus ax. So we already know that the first two roots. So 3 plus root 5. And then the conjugate root, 3 minus root 5. Now what about the rest of the root? It's supposed to be what? 5 roots, right? So the rest of the root right here, so we can take out the greatest common variable, x. So we do have x squared minus 2x minus 8. And then the rest of the quadratic, just factor it. So x minus 4, x plus 2. Keep that in mind, the whole thing, it's all 0. So that means x can be 0, x can be 4, x can be negative 2. So this one, those are the rational roots. So the rational root versus the irrational roots. Okay, so now let's see what else we have. And then the next one is quite similar. It's all about the long division. Okay, so the long divisions, again, dividend, divisor. So once you get a quotient, so you want to put it first. And then whatever the remainder that you find out, you want to put the remainder on top of the divisor. So the structure, once you do the long division, it's always quotient. Quotient is always the one going first. And then plus the remainder over the divisor. Okay. And now what about for 27 through 30? So let's see, the one that's kind of complicated. Let's do 30. Okay, so again, I'm going to snip this. So for number 30, now anytime that you see something like base e to the power, so the first thing that you're probably thinking about is the way to rewrite it from the highest power to the least. So started off with e to the power of 2z plus 18 e to the power of z plus 80. So what I'm doing here, I'm just swapping the terms around. So one thing you guys notice that e to the power of z, we can always set that as the variable. Let's say that's x. So this one basically is just written as what? X squared plus 18x plus 80. So once you're able to solve for x, you should be able to solve for z. So this one's a quadratic, and it looks like it's factorable. So let's see, 16 times 5, so then that'll be 80, but this one is 18. So besides 16 and 5, so let's see what else that we can use, 40 and 2, or 4 and 20. Okay, so it looks like this one is non-factorable. Okay, so the combo for 80, 16 and 5, 20 and 4, or 4 and then what else? 2 and 40. So none of those work. Okay, so basically this one you have to apply the quadratic formula. So negative b plus minus square root of b squared minus 4ac all over 2a. So negative 18 plus minus 18 squared minus 4 times 1 times 80 all over 2 times 1. So it looks like this one turns out to be, okay, let's see. So plus minus, so 18 times 18. $324 minus 320 all over 2. So it's negative 18 plus minus root 24 all over 2. Or negative 18 plus minus root 24 is just like what? 2 root 6 all over 2. So it's negative 9 plus minus root 6. So once you find out the value of x, so you want to set that equal to e to the power of z. Now keep that in mind. If you take the natural log on both sides, what happens if you take the natural log on both sides? It cannot be a negative number, because natural log of any negative number, then that would be an error. Okay, so this one's only restricted to negative 9 plus root 6. And also that turns out to be a negative number as well. So this one is going to be some kind of imaginary solution. But so far we're not dealing with things like those, okay? So the imaginary root. Okay, so far you can just simply leave the answer like this. So just say that z equals natural log of negative 9 plus minus root 6. Because everything over here, nothing's going on, so they're consider on the imaginary field. But so far you guys haven't learned about those. So basically just leave the answer like this. So z equals natural log of negative 9 plus minus root 6. Okay, so now let's see what else that we got. Back to the template. Okay, so now let's find the one that we can set up the real roots. Okay, so what about 31 to 34? Okay, so take a look at that, 33. So again, I'm going to snip this one. So this one is all about solving the exponential equation. Okay, so this one we can find out the real roots, not the imaginary. So now for number 33. Okay, so first thing that you want to do, you always want to isolate the term with the base e. So start adding 10 on both sides. So it's negative 83. And then divided by negative 5. So e to the power of 5x minus 0.4 equals 83 over 5. It's not a nice looking number. That's fine, okay? So we take the natural log on both sides. So we can get rid of that e. So 5x minus 0.4 equals natural log of 83 over 5. So this one is some kind of irrational constant. And then we just add 0.4 on both sides. So 0.4, that's just what? 4 over 10, so it's 2 over 5. So just leave that with all fractions. And then eventually divide everything by 5. And obviously this one can be simplified a little bit further. So it's like 5, 1/5, natural log of 83 over 5, plus 2 over 25. And according to the instruction, it's saying that you need to round it to the nearest thousands or round it to the nearest hundred or something. So basically just typing that to the calculator and try to approximate the final solution. Okay, so let's go back. So this one rounded to the nearest 10,000s. So that means it's 4 decimal places. And now what about 35 through 38? Okay, so let's do 1. And let's do 38. So anytime that I see the natural log with 2 natural log on one side, so that means you need to apply the properties of natural log. So the condensing properties with log or natural log. So we'll take a look at that. Okay, so again, copy and paste. So one thing that we notice for the natural log of x minus natural log of y, it's always written as natural log of x over y. It's a difference to quotient. And the other property is like sum to product. So let's say that we do have natural log of x plus natural log of y. Then that would be considered natural log of x times y. And then the third property is that the coefficient. So we can always bring the coefficient back to the power. So r times natural log of x is the same as natural log of x to the power of r. And this one, since we do have those binomials, so they are considered one singular quantity. So this one is considered natural log of the quantity x plus 5 over the quantity of x plus 3. So that equals 5. So basically I'm just using the first property, difference to quotient. And then in order to get rid of that e, so just take base e both sides, because e to the power of natural log is just 1. So basically this one is a quadratic, well it's not quadratic, it's a rational expression versus the exponential constant. And then this one we can cross multiply, so x plus 5 equals e to the power of 5 times x plus 3. And then distribute e to the power of 5 times x plus 3 e to the power of 5. And then collect the variables all together, so it's x minus e to the power of 5x. So that equals 3 e to the power of 5 minus 5. And then on the left hand side, so we take out the common variable, GCF, greatest common factor, x. So what's left here? It's just 1 minus e to the power of 5. And then the right hand side, nothing we can combine because one is irrational, the other one is rational. So basically just leave that with a binomial. And then eventually divided by 1 minus e to the power of 5. And that would be the final irrational expression. Okay, so now let's see what else. So that was 38. And let's see. So, and the other one that I would like to show you here is solving the rational equations. So for the rest of this, so I'll set up another video and later today, so you guys should be able to see that soon. So solve each equations. Remember to check the extraneous solution. It's very important for you to check the extraneous solutions because sometimes once you find out one of the solution is not balanced, so that means it's considered the extraneous solution or the invalid solution. And for this one, I would like to show you one of those. Okay, let's take a look at that, 41. So that one looks a little bit crazy. Okay, so again, snip. So once again, rational expressions or rational equation, that means you'll see the variable in the denominator. Okay, so here's what we have. And first thing that you want to do, you want to factor it because you want to find out the least common denominator. But before we do that, so we need to factors to find out things that they share in common. So v squared plus 2v minus 48. So that it's written as v minus 8, no, v plus 8 times v minus 6. So two different ways you can do it. You can find the common denominators, just convert all of them to the least common denominator. Another way you can do that is just simply multiply the least common denominator, distribute, and then you'll see that there's no more denominator left in the expression or the equation. Okay, let me just rewrite this part right here. So v plus 8, v minus 6. So obviously this one, the least common denominator, it's considered v plus 8 and then v minus 6. And then once you distribute, this whole thing is gone. So what's left here on the left hand side is 3. And then v minus 6 is gone with v minus 6. So what's left here is just 8 times v plus 8. And then this one right here also, the whole thing is gone. So what's left is just 1. And now as you can see that there's no more denominator remain. And then for the rest of this, distribute. So we got AV plus 64 plus 1. So that equals 3. So this one basically just solve for the variable. So combine them. So plus 65. Subtract 65 both sides. So we got negative 62 equals AV. So V equals negative 62 over 8. And this one you want to reduce by 2. So that turns out to be negative 31 over 4. So if there's only one solution, there's no need to check your work, because this one always guarantees that there's at least one solution for the equation. If that's more than one solution, that means you need to plug in a number back to the original equation and find out exactly whether that they're balanced or not, both sides, okay? So this one is actually, it's a valid solution. So there's no need to check the work. Okay, so now let's see what else. Okay, so again, as what I said earlier, so the rest of this, we'll talk about that on the next part of the video. So just stay tuned. So the way to solve for the trig equations. And that's something we're going to cover that soon in class. And also the review for the composition functions, f of g of x or g of f of x, things like that. And also finding the roots by using the rational zero theorem, p over q. And also, let's see what else. Solving sequences in series, geometry. And also the summation, sigma, with the geometric series. Again, I in the series, it's not considered in imaginary notation. So that's just the variable. And also we'll talk about the inverses trig functions. And also graphing with transformations, all that, quadratic, absolute value, cubic, roots, rationals, and also the trig functions with the parent graph, all that. And also finally we'll get into the identities, using the identity to find out the exact value for the half angle, sine, cosine, tangent, secant, cosecant, and also verifying the identity. Alright, so just stay tuned, so I'll see you guys soon. Again, if you guys do like the video, so please subscribe to the channel, and also make sure that you click the bell, okay? Because anytime if I post up any kind of latest video, you guys will be able to find that soon, okay? So that's pretty easy to do. And I'll see you guys later. Have a great one, everybody. Take care.